Welcome to the video. I am Prithvi Kishan from MATLAB Helper, and in this video we are going to perform tweet analysis and Twitter sentiment analysis in MATLAB. This is the MATLAB code to perform tweet analysis and Twitter sentiment analysis. The prerequisites for this program are 1. You must have a Twitter developer account and its credentials, and 2. You must have the text analytics toolbox installed in your current MATLAB version. To get more information on how to create a Twitter developer account and get its credentials, you can visit the links shown here, which will also be mentioned in the description down below. All my Twitter credentials are saved in a mat file called twittercreds.mat, and we then load it on to our program for privacy. The next step involves creating a Twitter object, which is created using the Twitter function and is stored in the variable connection. The Twitter function requires your Twitter credentials, namely consumer key secret, access token secret, which we have stored in twittercreds.mat. When we run this code, we see that we get a Twitter object whose status code has a value of 200. This means that the connection is authorized or successful. Then, to make a Twitter search, we can use the search function, which has the following syntax. The first argument is the connection, which we have already defined. The second one is the search query. The third one is the count or the number of tweets. And the fourth one is the language of choice, which in our case is English. Do note that you can retrieve only up to a maximum of 100 tweets at a time and also up to 7 days of historical tweets. For more details on search query documentation, you can visit the link shown here. To make a Twitter search from an individual, the search query, which is the second parameter in the search function, has to be a string in the form of starting from having a colon followed by the handle without the at of that individual. In our program, we are first going to analyze Twitter data of a very successful and highly followed entrepreneur, Elon Musk, whose at handle is at Elon Musk, but we only require the text Elon Musk. When we run the search command, we get a response message which is stored in the variable response. This response message has all the Twitter data stored in it, which can be found from the path response response.body response.body.data response.body.data.statuses, and finally we get structures which contain all the Twitter data, as you can see, in the form of the text, the number of retweets, and the number of likes. We can then retrieve tweets by applying self functions to the field text in response.body.statuses, which convert each of the cells into strings and store it in tweets. Similarly, we can do that to get the retweet count and the likes count. And to get the tweet date, we basically have to convert it into a number at the locations 9 and 10. This is because the date appears in the 9th and 10th index in the string created at. We can now retrieve the tweets, the retweet count, the number of likes, and the tweet date. I can see that we get the tweets in the form of a 51 cross 1 string. These are all the tweets that we have retrieved. Retrieving hashtags, mentions, and links takes a different approach, which can be understood by first running the program. Ment is a 51 cross 1 cell that includes all the mentions used in the tweets. We see that the first cell has a mention, whereas the 18th cell does not have any mention. If we examine response.body.data.statuses, we see that the first cell in entities and user mentions has some values, whereas if we go to the 18th one, we see there are no user mentions. To retrieve the mentions, we first use a for loop to iterate through all the mentions. Then we check if the cell has a structure, and if it has a structure, we take the name field of it and assign it to the mention. Else, we make mention a empty cell. We can make plots to see the popularity of the tweets using histograms. This is the plot that shows the number of tweets tweeted on each date. This is the plot showing the likes counts of the tweet. And this is the plot showing the retweet counts of all the tweets. We now make use of the text analytics toolbox in our program. A word cloud is an image composed of words used in a particular text or subject in which the size of each word indicates its frequency or importance. So basically, the word which is more important or higher frequency appears bigger and bolder. We will now examine how we can make word cloud of tweets in our program. We first have to make a tokenized document, that is, a document represented as a collection of words used for text analysis. We make a tokenized document of tweets and store it in the variable tweet list. Then this variable tweet list is cleaned by using the remove stop words, erase punctuation, and remove short words functions, which are part of the text analytics toolbox in MATLAB. We can then pass this variable tweet list to the word cloud function, which automatically prints the word cloud image. We can examine how the document looks like after passing it through each of the above mentioned functions. First, the tweets are converted into a tokenized document called tweet list. Basically, a tokenized document is a collection of words that are represented in a document. As you can see, the first one is a 1 cross 25 string, each having a word. Then we can remove all the stop words. We see that it results in a 1 cross 19 string. That means 6 words are removed. We can then remove any punctuations present in the tokenized document. We can see now it's a 1 cross 14 string where all the punctuations are removed. Then we can remove any short words, and we see that the tokenized document is only 1 cross 12 string array. Hence, tweet list was reduced from a 1 cross 21 array to a 1 cross 12 array after cleaning. The same functions can be applied to the list of mentions and the list of hashtags, and they can all be passed to the function word cloud to visualize it in the form of word clouds. Let us run the code. These are the word clouds of all the tweets by Elon Musk. These are the word clouds of all the mentions by Elon Musk. And this is the word cloud of all the hashtags. Since he does not use any hashtag in his tweets, it remains an empty image. A similar visualization can be done for tweets from NASA by just changing the search query. After searching for tweets from NASA, we go back to the section we were previously in. We then run this section to form the word cloud images. As you can see, this is the word cloud of all tweets from NASA. This is the word cloud of all the mentions from NASA. And this is the word cloud of all the hashtags from NASA. That looks something like this. An n-gram is a continuous sequence of n items from a given sample of text or speech. When n equal to 2, it represents two words in succession, and these are known as bigrams. Bigrams can be created in MATLAB using bag of n grams and passing the tweet list parameter, and this is stored in bag 2 grams variable. Similarly, we can create a trigram, which is three words in succession, using the same bag of n grams function and passing a parameter name value pair, which is n-gram length. We can then create word clouds for the bigrams and trigrams present in the tweets. This is what bigrams from the tweets look like, and this is what trigrams from the tweets look like. In the next part of the code, we are going to examine LDA topics. Topic modeling is the process of identifying topics in a set of documents. LDA stands for Latent Dirichlet Allocation, which is a topic modeling method based on generative statistical model. The fit LDA function is used to create LDA topics in MATLAB. We pass the parameters back to grams, which is a variable that contains the list of bigrams, and 4, which is the number of topics we want to create. Then we can produce the word cloud of all these LDA topics using this for loop as shown. We can see that there are 4 topics, and the first topic has outside space station and partner CNES as the topic. The second topic has Happy International Women's Day as the main topic. The third topic has Kate Rubins as the main topic. The topic 4 is Women NASA. Hence, LDA topic modeling is an easy way to determine topics that is given in a specific document. Sentiment analysis in MATLAB can be performed using the ratio sentiment scores function. This function determines the ratio of positive to negatively scored words in a tokenized document. It returns a value of 1 if there are more number of positively scored words compared to negatively scored words. It gives a value of -1 if there are more number of negatively scored words compared to positively scored words. If there are equal number of positive and negatively scored words in a tokenized document, we get a score of 0. All the scores are stored in a variable called scores. We pass the parameter tweet list, which is a 100 cross 1 tokenized document. Executing this score, we get a 100 cross 1 array which is stored in the variable scores. This variable contains the scores 0, 1 and -1, which represent neutral, positive and negative sentiment respectively. We can now plot a bar graph of all the individual scores. This bar graph represents the sentiment scores for all the individual tweets in the tokenized document tweet list. Performing and comparing the sentiment analysis of different topics will be a good way to understand and compare the public's view on different topics. In this part of the code, we store the topic names in the form of a string array called name. Then we have an array called sendscore, which holds the value of the average sentiment score for each topic. We then make use of a for loop which searches for one of the topic names in each iteration and stores it in the variable response. We then use self functions as we did before to extract the strings from the given path, which is response.body.statuses. We then convert it into a tokenized document and store it in the variable tweet list. The text of the tokenized document tweet list is then cleaned using the functions remove stop words, erase punctuation, and remove short words. We then calculate the ratio sentiment scores of tweet list and store it in the variable scores. We then calculate the average value of the scores of tweets of each of the topics and store it in an array sendscore. Scores is a 100 cross 1 array which contains the sentiment scores of each tweet of each of the topics. Send scores is an array that contains the average sentiment scores for each of the topics. To better understand the sentiment scores, we can visualize it in the form of a bar graph. This bar graph represents the sentiment scores of 4 topics, namely tweets from the user Bill Gates, tweets with the hashtag corruption, tweets with the text Olympics, and tweets with the hashtag Bitcoin. As we can see from the graph, tweets from Bill Gates have an overall positive sentiment score of around 0.45. Also, tweets with hashtag corruption has an overall negative sentiment score as expected. Tweets containing the text also seem to have a positive sentiment score of around 0.27. And lastly, we see that tweets with the hashtag Bitcoin has an extremely high positive sentiment score of 0.73, which makes sense and is in accordance with the trend of the Bitcoin value, which has increased in the recent years and in particular in the recent months. And the same can be said for its hype and popularity on social media platforms like Twitter. Also, more topics can be compared by just adding it as a string to the name array. Hence, we have performed tweet analysis and Twitter sentiment analysis in MATLAB in the form of making plots of tweet popularity in terms of the dates, the likes counts, and the retweets counts of the tweets, making word clouds of all the tweets, all the mentions, and all the hashtags, and also making n-grams and trigrams from the data for better visualization. Also, we have determined many topics from each of the documents in the text. I also performed sentiment analysis and provided scores to the average sentiment of all the tweets in the document. We can also compare the sentiments of different topics as we have done. A similar analysis can be performed on other data as well. In a world where text-based communication is drastically increasing, the volume of textual data produced as a result increases exponentially as well. These analytics methods help us to make sense of the massive archive of textual information. Hence, the scope of Twitter and other text-based analysis will be on the rise for years to come. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments or get in touch with us. Follow us on LinkedIn, Facebook, and subscribe to our YouTube channel. Education is our future, MATLAB is our future. Happy MATLABing!